Now in first step at TL494 check 12 volt with respect to ground, pin number 7, pin number 12 and pin number 7. Pin number 7 is here and pin number 12 is here, 9, 10, 11, 12. So it is varying voltage. Assalamu alaikum wa rahmatullahi wa barakatuhu. We are going to discuss about smart battery charger. It is 26.7 volt, 26 volt and 27 volt output. This battery charger have facility to give output as a battery charger, or we can use it as a battery source, as a SMPS, switch mode power supply. It have dual function. Here it is charging level selector, 27 volt, 26 volt, 27.6 volt, like this. And here we have battery type selection, gel flooded battery. We can say sealed battery and liquid battery. Different conditions: charger on, float, absorption and bulk. All settings. Here it is fan connector, input side, it takes AC input. And now we will discuss basically how its circuit is working, and if you find a fault, how you can locate the fault. If any battery charger is not working, that means it is not working. How we can define, how we can locate where is exactly the problem or which area is affected. Input connector, fuse, protection circuits, surge protector, RLC filter to remove the noise, spikes and electromagnetic induction. Then we have rectifier, bridge rectifier, BR1008. After that we have two capacitors. These are 250 volts, 470 microfarad in parallel. Sorry, not in parallel, in series connection. Every capacitor, it have its own NTC in series of charging. Then we have signal transformer. Then we have power transformer. We have TL494 IC. Here we have TL494 and its circuit. TL494, it is dual channel switch mode power supply controller, PWM controller. And here we have LM339 comparators, and we have CA3140 operational amplifier. Then we have power transistor as a regulator, current sensor, protection fuse, reverse polarity protection diode for battery. If you connect reverse battery at this point at output terminals, this fuse and these diodes will protect the next circuit, because if we connect the reverse battery, that means the reverse current can damage this circuit. So these diodes will bring this fuse in series and they will put a load, same like in this portion the over voltage protector MOV is working and it burn out the fuse. The same, if battery is connected in reverse polarity, that time these diodes will allow to flow the current from this fuse. So in that case, this blade fuse will burn out, this 15 ampere fuse. And here we have output capacitors, and we see the circuit now. If you look at this point, one line, neutral. This line and this line, here are 2 points. The third line, this one, is ground. is ground here. This ground is connected to chassis ground. From this point we have these two connections, so that means this line will be connected here. So what is here? Here is fuse. So current coming from this point should pass from the fuse. So our current will pass from here through this fuse in this point, and it's coming here, and neutral line is coming directly here. So now we have to see here something. What is there? At this point we have this MOV, metal oxide voltage arrestor. It is for high voltage arrestor. If there is a high voltage spike, it will become short. When it will become short, at that time the current will flow at this point. Very humble request. When I share something, might be I am sharing something wrong. If you think this should be a corrective, here we need correction, so we must share our experience, and it will be your huge contribution to make correction for my work, for my sharing, and I will personally thankful for your this contribution. If any time you need to some suggestion, kindly make a comment, and if there is a mistake, please write down in comments, and I will personally thankful for your this input. So let's move forward. Then we have here a capacitor. After capacitor, our both lines are here. Here we have inductor. After this inductor, there is a resistor as well there. We have this resistor here. Then we have this bridge rectifier. It is BR1008. It is 35 ampere bridge rectifier. So this terminal and this terminal is bridge rectifier. From this point to this point. Because it is double-sided printed, this board have print from double side. So double layer print and multi-layer print, sometimes it becomes too difficult for tracing, but no problem, we will discuss whatever we can. This point is AC input terminal, and this point is AC input terminal. It is coming from this point. From this side we have this output and we have this output, these two output terminals, and here this terminal is positive. I will make red color for positive, and this terminal is N terminal, negative terminal, and here we have NTC, and here we have NTC. From this point to this point, NTC, here is NTC, this one, and then there is another NTC. So two NTCs, negative temperature coefficient resistors, are connected in series of every capacitor. So this capacitor, it have this point and this point, this point and this point. So the central point is common. Positive voltage, negative voltage. Let's see the capacitors. Here it is negative side, and this capacitor negative side is inside this one. So this one is positive, positive, negative. So center point is common. So we have here 300 plus volt. What is the input voltage we will receive here at both capacitors? These both capacitors are in series. So that means if we have two capacitors in series and we have four transistors here, 13009 J13009, that is NPN power transistor for high voltage, and it is used in pairs to drive this power transformer. When it will drive, in first it will give a soft start, this network, resistor network here, it will give a soft start, and at first pulse it will generate some voltage, and its voltage will be transferred in output side, and in output side there is STPR 1620 CT. It's common cathode bridge rectifier. From the center point of these rectifiers we will take output, and this output will be filtered from this output filter, power resistor, jumper resistor 50 ohm, and then here is current sensor. Then this voltage will pass through this fuse, and after that these will be applied to these capacitors, and we will take these voltage at output. Here is SMPS controller. When the first pulse will start, the same time in the input side there are two outputs, and there is full wave rectifier from these two diodes, and these two diodes will apply voltage to this capacitor, and this voltage then passed through this diode and applied to this capacitor for working of TL494. This 494 will start oscillation. When it will start switching, so its switching will pass to these two transistors here, one transistor and two transistors. These two transistors will switch to signal transformer, and signal transformer will give output to this pulse forming network. Here is diode, capacitor, resistor, and these will apply output pulses to these networks in pair, and these will start switching, and it will control the output voltage. Here the comparators, these comparators will check the function, what is the required. All these inputs, all these switch inputs, what we need will apply to these comparators, and what is the battery level, it will monitor through this operational amplifier. And when we are working in SMPS mode, at that time it will also monitor the output voltage level. Here are adjustments for the output voltage for flooded battery and gel battery. We can adjust the voltage here, and in SMPS mode we can adjust the voltage from here. And here is the charging level. The charging level 27 volts, 26.4 and 27.6. It is actual two battery charger, double batteries in series, 27, 27.6, 27.4, 27.6. So 27 plus minus 0.6. We can adjust the voltage here from this switch, and this level will apply to this operational amplifier, and this will monitor the required voltage level, this voltage, the switch setting here. What is the switch setting? Actually what we do, we apply a voltage level. This voltage level will apply to this operational amplifier, and it will check the output level in case of battery charging, and in case of SMPS it will also monitor the voltage level, 27 volt, 27.6, 26.4 R voltage. It will monitor the output voltage. It will give a feedback to this TL494, and the function of the system, how the charger is working, is the charger connected, will sense by these comparators, and these will be displayed: charger on, float, absorption, bulk. All the indications will be monitored and displayed on the display. Let's check the function, how it's working. I will apply power. If you don't have a good practical knowledge about electronics, power electronics, never try this one. Never apply power, and while working you must be aware for the safety. So let's see the IC circuits. Here we have TL494. So TL494 basically is switch mode SLPS controller. It have two channels, two outputs. C2, that is output number 2, 8. Number 8 pin and number 11 pin is output. 11 and 8 output. 7 is ground. RTCT, it is the frequency, timing frequency, because this IC is fixed frequency oscillator. What component we connect here in the input side? 5 and 6. This will adjust RC time. Its formula is 1.1 divided by RTCT. So you can calculate the output frequency. Then here is dead time control. What is dead time control? The time gap between the first channel and the second channel. If you want to give a time output at pin number 11, how much should be delayed? After finishing this cycle, how much delay we want to adjust, we will adjust from this dead time control. This compensation pin, PWM control input, non-inverting, inverting input. It is dual channel, and it can be work as master slave operation. And here is V reference. It have its internal 5 volt reference. Then we have output control. This output control circuit, it is the basic key. If here we apply 0 volt, this IC will go in disable state, and if it is high, it should work. VCC voltage, here is VCC for this IC. It is 8 volt to 20 volt. When these voltage are available at pin number 12 and RTCT is connected, then this IC should work. And all these inputs, in non-inverting and inverting input, what are these? At one input we give a reference, our own standard reference. Suppose I apply 2 volt, and when this IC will start work, from the output loop we give a input to the second pin. So it will compare our given reference with our output. If both are matched, then it will adjust its duty cycle. Otherwise, it have to increase or decrease. If these two inputs from here and here for both channels, if these both are not equal to each other, that time it will adjust its duty cycle to meet our requirement. Power supply 42 volt maximum. Its maximum rating. For normal working condition, it is 8 volt to 20 volt are applied here, and it is its sample circuit. How this IC is working actually. Number 5 and number 6, here is RT and CT. RT is resistor timing, CT is capacitor timing. So these timing components, these control oscillator. Then we have output control here at pin number 13. It will enable or disable the output. It should high. If it is high, it will give output. Otherwise, it will not allow the output. Here we have error amplifier number 1, error amplifier number 2. It is for feedback. One is given reference. Second, it will check the outputs. Reference output, ground, and here we have VCC applied here at this pin. Then we can take output from pin number 8 or 9. How we are working with this, how we are using, we are taking output from pin number 10 and 9 or 8 or 11. How we want to drive. If 9 and 10 are connected to ground, then we will take pin output from pin number 11 and 8. It depends upon the designer how it's working. So here it is wave shapes and outputs of the Q1, Q2 emitter or collector. So here it is shown as output of the emitter. So Q1 emitter and Q2 emitter. In other ways, it will show Q1 collector and Q2 collectors. This is a typical circuit. 8 volt to 20 volt input at VCC pin. Pin number 2 and 3, 15 and 16. These are the inputs. Output control. Here is output control to enable the input. Then we have V reference, and V reference, as I told, we give a standard reference. We generate a reference what we need, and then it will check the output of the circuit, how the circuit is working. That is pin number 16, and pin number 1. The same is here. Pin number 1 is connected to this point, so it is feedback. It will take the output. Pin number 2, as we discussed, we generate a standard reference. So here is a standard reference here. V reference, this resistor is connected to this pin. So here we give a reference. We need 5 volt, for example. We adjusted this resistor to take 5 volt. Suppose I apply 2.2 volt. When it will take 2.2 volt feedback here, that time this IC will adjust its duty cycle. If the output voltage are up or down, so it will increase or decrease the switching. Then the second reference we adjusted from here, that is pin number 15 and 16. So pin number 15, it's connected here. So it will monitor the upper and lower voltage, and it will adjust the pulse width at pin number 8 and 11. 8 and 11 is driving these transistors, and these transistors will connect it to this transformer like here. So this sample circuit is exactly matching. Here we have capacitor here. Then there is this BR1008. Here is BR1008. It is 35 ampere, 400 volts. What is that? This component. Then we have LM339, 339A, 239, 239A, 2901. These ICs. It is comparator. Quad single supply comparators. This comparator, it have 4 comparators inside. Pin number 76 input, 56, 54 input, 89 input, inverting and inverting. What is its function? I will discuss in upcoming video. It will compare the 2 inputs, and then it will give a true or false output. If the both inputs are matched, it will give, suppose it will give high output, 5 volt. If there is a difference between the voltage, it will give 0 volt. For example, how the designer is designing the input side. It will compare the inputs and it will give the output. CA3140, it is operational amplifier, and this operational amplifier, it have BiMOS operational amplifier with MOSFET input, bipolar output. So it is bipolar output. It has dual supply, plus and minus supplies, inverting and non-inverting, and it have output. It becomes in CAN pack. If CAN pack, we can use these pin numbers. If it is dip package dual end line, so that time it is 8 pin here. Then we have STPR 1620, so it is common cathode rectifier, and we have 2 by 8 ampere diodes, 200 volt. So I will attach all these data sheets in the description. You can find the link in the description for all data sheets. So FJP13009 high voltage fast switching transistor, it is 12 ampere 400 volts. I will apply power and we will see the circuit. First of all, because this time the circuit is removed from the heatsink, this workbench must be clean. There should no any solder parts or wires or anything. And when the power is applied, never touch to any component, and always use series lamp. So I applied voltage, set multimeter to AC, check voltage at input terminal, that is 227 volt. One line is here, 227. Add the fuse, there should no voltage. If there are voltage on the fuse, that means the fuse is open. So this time there is no voltage on the fuse, that means it's good. Across the fuse, if we will check like this, we should find voltage. Check in the output, we have voltage. Then we have to check on the RLC filter, we have voltage. Check voltage at the bridge rectifier, it is input voltage of the bridge rectifier. Now switch to DC and check this point and this point, it is 316 volt DC. Then these voltage are applied to this NTC. So NTC have no drop, it is 0.006, that means it's working. If we find full drop across the NTC, that time the NTC should open. Now we can check the voltage across each capacitor. It's 157 volts, 157. So both capacitors are in series, so we can check voltage like this. It is 315 volt, the same output of the bridge rectifier. 315, the same voltage should here. And if we check individual capacitor, so it is 157, 157. Now these voltage are applied to these transistors and the switching network. Then these voltage will pass at these 2 points, 1 and 2, and this is common. So this voltage will rectified and this voltage will applied to capacitor here, and then we will find the voltage across this TL494 capacitor, VCC capacitor of 494. So what's there? It is here. If we see, VCC capacitor is not giving a good output. It is not stable. It is the first indication that this charger is not working in perfect ways. Why? When the VCC voltage of this IC at pin number 12 and 7, pin number 12 is VCC, 7 is ground. So if we cannot find the voltage, proper voltage here is pin number 12. So VCC voltage of this IC should be stable. VCC voltage of this IC should stable. I am checking at pin number 12 at VCC pin and ground. So we have fluctuation. It means our circuit is not working properly. So we have to check the output of this rectifier section. We can see I am finding 12.34 volt. It has fluctuation in the output. This is negative line and it's positive line. Then the output of the main filter, it's not good. Then we have voltage here. We have fluctuation. If we check the fuse, If any fuse is giving a drop voltage, that means the fuse is not good. So let's remove the power. I remove power. So here is blade fuse. I have to remove this fuse. This 15 ampere fuse. Check fuse. It's open. We can see there is a path break. Blade fuse, path break. Yes, this blue color 15 ampere fuse. So it's the same. So we will correct this one and then we will check. Now I will connect power. This time we have output 27.4, and now I will remove the fuse and we will check output. I will now install the original fuse. We have no output. We have no output. Never touch any component in the board when power is applied. Always disconnect power before working on power electronics. So now I will check the voltage on the fuse. It is 0 volt. The fuse was open. It was showing full voltage. In electronics, when any component is open, it will show the full supply voltage. And now I am finding 27.4 volt here at the output. Now I will check this switch. It is 27.4 volt, 28.75 volt. In this point it should give 27 volt. It is giving 27.4 volt. So its upper and lower limits are to be adjusted. For SPMS operation in both mode it is good. SPMS and charger mode, it's good. Gel battery and float battery, it is working good. This time the battery is not connected, so charger is on. This indication is on. That means the charger is working. So that means this charger is working now, and we have just only the fault in this fuse. We will adjust the outputs because it should be in the center point. This should center, and we must adjust it at 27 volt. 27. Nice. It is 27 volt now. It is 28.1 volt, 27.54. That's nice. Now we have to check pin number 8. 1 2 3 4 5 6 7 8. This is 8 and ground. It is 9 kilohertz. 9 kilohertz at pin number 8, 9, 10, 11. It is also 10 kilohertz. 10 kilohertz. 10 kilohertz. 10 kilohertz at one channel and 10 kilohertz at second channel. And we have these comparators. These comparators compare and check the function of the circuit. Now in not working condition, when it is not working, we can check this fuse. It is giving 12 volt. There is 12 volt drop on this fuse. Why? Because this fuse is open from inside. Now in first step at TL494, check 12 volt with respect to ground, pin number 7, pin number 12 and pin number 7. Pin number 7 is here and pin number 12 is here, 9, 10, 11, 12. So it is varying voltage. It has fluctuation. So if we check frequency, now if I check frequency at pin number 7 and 8, 7 is ground and 8 is output. So we have fluctuating frequency. Why? Because this time IC is taking in restart mode. How it will go to restart mode? We will monitor pin number 2 with respect to ground and pin number 1 with respect to ground. Pin number 7 and pin number 2, it is a standard reference which we demand from this circuit. This is our requirement. This reference we adjust that after full function of this IC we need this level, and this level should be present at pin number 1. So pin number 1 is not stable. Why? Because this fuse is open and this voltage are not reaching at end terminal, because this IC sends the output from end terminal. Because it is terminal regulation, it will give a standard voltage at this pin. So pin number 1 have fluctuation because pin number 1 is feedback. So pin number ground and 11, 9, 10, 11 set to frequency. It have fluctuation from 1 kHz to 100 kHz. Why? Because it is in burst mode. Now I will replace the fuse with the serviceable one, and then we will check these outputs again. These are the working conditions for this TL494. This fuse, unserviceable fuse, and I am going to replace with this serviceable fuse. Before that the LED was not working. Now I will connect power and we will see these LEDs are glowing now, and we will check first of all the VCC voltage at pin number 7, 9, 10, 11, 12. Now it is 26 volt stable. Before that it was varying from 16 volt to 22 volt. Now it is stable. Now we will monitor pin number 1 and 2. This is our given reference. Pin number 2 is given reference and pin number 1 is feedback. This IC will keep adjusting its duty cycle until it take the same voltage at pin number 1. When the fuse was open, it was not taking the output, so this IC was making burst, start, restart, start, restart, so that there was a big fluctuation at VCC capacitor and pin number 7 and 12. Now the pin number 1 is stable. Pin number 1 is stable, so this IC is working properly. Now we will check the voltage at this fuse. The open fuse was giving full voltage, but this one is no giving voltage. There is no voltage drop across the fuse because this fuse is good and we have output in the output terminals. we have 27 volt. That's nice. So friends, I hope so this video is good for you. If it is good, remember me in your prayers. Thanks for watching. And if you find some information, you can like it if you want. And if you want to watch my future videos, you can press bell icon button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.